Hello everyone, March 22nd. Alright, let's take a look what we have today. First of all, check this. Hey, I remember this question, find median from data stream. I actually forgot how to solve it, but this is an interesting question. Anyway, nothing to be of concern. Alright, let's go to it. Oh, we start a new week. Vowel spell checker. Okay. Alright, given a word list, we want to implement a spell checker that converts a query word into a correct word. Okay? Don't know what that means. For a given query word, the spell checker handles two categories of spelling mistakes. Okay? Capitalization. If the query matches a word in the word list case insensitive, then the query word is returned with the same case as the case word. Okay, so if I have this, I query this, I return this, right? Is that what it means? Alright. Vowel errors. If after replacing the vowels of the query word with any vowel individually, it matches the word in the word list, okay, then the query word is returned. So if I have YOLO, I can swap O with E. Okay, if it's this, then we cannot match. Then the correct is no match. If it is this, it's no match. Okay, this actually seems kind of similar to the ones we had yesterday. Yeah, actually looks very similar, right? So we just do a counter, right? We do a counter between the query and then this, and yeah, I'll do a counter, and then we need to see if the total length is the same, and we need to see, no, we need to see, it has to be all the consonants match, and then we have the same number of vowels on both of them, and then we can count as match. Alright, finally, in addition, the spell checker operates into the following. When the query exactly matches the word, you should return the same word back. When the query matches a word up to capitalization, you should return the first such match in the word list. Oh, what does it mean? When the query matches a word up to capitalization, you should return the first such match in the word list. Does that just mean we just match? Oh, okay, the first capitalization. When a query matches a word up to capitalization, you should return the first such match in the word list. So I'm looking at kite, right? Kite, I don't match. This actually is a match, right? It's a match, and then this is also a match, but this is a better match, so we return this. Kite is a better match for this, so we return this. How about this? This is what it means. When a query matches a word up to capitalization, you should return the first such match in the word list. Up to capitalization. Oh my god, look at this. It's way too long. So up to cap. So if I match, and then up to capitalization, I match. So if I match the capitalization, I return that word. Is that what it means? Yeah. So like kite. You know, match up to capitalization. Okay, we match up to capitalization. So this one does not match capitalization, right? So I skip to this, and it matches everything. Then return this. This K, we match the capitalization, so I always return this. This is hair, should return this one. How about this? Return And this, we return this one. Let's keep reading. When a query matches a word up to vowel errors, you should return the first such match. If the query has no match, you should return an empty string. Given queries and the list of words answered are correct. I think the difficulty is to understand the rules for the matching. So these two rules are simple to understand. Just to check to see if it matches or does not match. And then these are the rules. If it matches exactly, you should return that word. Okay, that makes sense. When the query matches a word up to capitalization, you should return the first such match, up to capitalization. When a query matches a word up to capitalization, so I match up to the capitalization. Or when a query matches a word up to vowel errors, you should return the first such match in the word list. I don't understand these two. I don't understand. This is way too long. I want to put it in a better format so I can just take a look better. Okay, so this is the one, this is the queries, and this is the answers. I'm trying to figure out what the rules actually are, because I don't understand. Okay, kite, we have a direct match, so we return this. That's good. This kite, we have a capitalized letter at the beginning. It says when the query matches a word up to capitalization. Up to. Match up to. What does that mean? Match up to. What does it mean? Match up to. Oh, that's wrong. Up to. Okay, let's go Merriam-Webster. To be equal to succeed in that's match up to. Oh, that's a different word. That's a different meaning. Huh. Match a word, right? I match up to capitalization. Is it until capitalization? I don't understand. So kite, this one matches to this. It's fine. But this one I match to this. First such match. That means that if I have a capitalized letter matching, I always take that as precedence. Keep going. Hair, because I have direct match. Hair, I match to this instead of this. Why? And a query matches a word up to capitalization. This one does not match. Well, my match here. I don't understand. What the hell? What the hell is this rule? Let's keep going. Here, which gives us no matching because I have, because the R is in a different position. Oh, we cannot use counter then. It's on a different position. Here is not right. This is not. This one will match to this because I can swap. Okay. And then it probably follow this rule. When it matches up to a vowel, so it match up to a vowel, and it will match this also up to a vowel. But also if match up to a capitalization, which means this is the match to capitalized. This one is not right. Keto would match to this. Why? I don't like kite. matches to this, because I match up to the first capitalized letter, up to a capitalization. So this one matches up to capitalization. This one also matches up to capitalization. And then we return the first such. Is that what it means? Can you find some interesting counter examples? Let's see. Okay, let's try some examples. Just help me understand. So, what if I say K and then ITE, right? KIT. I think the first match up to the first capitalization. So this should return the first one, right? So anything will return the first one, unless, what if I do K, right? So match until capitalization. KITE. How about this one? So I think this will return the first one, because actually I don't know. So this is a capitalized letter. This is a lowercase. So if I get the lowercase, I say match to this one. And this one will be matching. The first three is matching here. And then this one is the first non-matching capitalized letters. But here, the first non-matching capitalized letter is the first one. So this one I expect to return the smaller kite. All right, which is the. I think I don't like this. No, it must still match the first one. I don't understand. What is the rule? What is the rule? Like everything is going to. Hold on. So we have kite. I know this one matches second. Yeah, I'm doing this. Like, just I'm trying to understand. TE, and then KITE, and then KITE. All right, so we're swapping the capitalized letters around. So only the first one matches here, and everybody else matches the first one instead of the second one, because we have now this one is because it's this one also matches to this instead of to this. What is the rule? When a query, okay, my query word matched a word up to capitalization. What does it mean, up to capitalization? Or matches something up to something. Match something up to something. What does this mean? Now, this is not match up to. Up to, I understand, is until. I mean, we got stuck in this question because we don't know the rule. What the hell is the rule? We're going to match a word, right? Match a word up to capitalization. You should return the first such match in the word list. Does that mean if the match requires changing in capitalization, then you should return the first such match? This means if the match requires changing of vowels, then you should return the first such match. Okay? If we apply this rule, this one does not require anything, so we return this. This one requires change in capitalization on both, so we return the first one. This one requires capitalization on both, changing the first one. On both, for the first one. This one on both, so return the first one. Okay, that's good. Let's look back here. So if we use this rule, we can explain the first three. And this is exact match. Good. This we require capitalization on both, so return first one. That's good. This is not. This is not. This one we require vowel changes on both. So we require vowel changes on both, and we require capitalization on this one. So no. So which one takes precedence? A vowel change, right? So vowel change, then we return the first one. So it requires vowel change on both, so return the first one. This is bad. This requires vowel change on both, so return the first one. Okay. Okay. Is it possible that we return this one? We cannot return this one because these two are exactly the same. So if we have a vowel change, it will always go to the first one. Capitalized change. If there is a capitalized change in this, but not in this, then we go here. Yeah, that's the only thing. Is it possible that we have a capitalized change will always go? Yeah, it's always going to return the first one then. I mean, it depends. It didn't really say in the word list how the things will order. We can order them anyway, which means let's order them anyway, right? Let's do. Yeah, let's change the order, right? Change the order and see if things is different. We use the given query, but instead of doing, we just change the order. So we're gonna move this one here and move hair here. All right, let's see the result. See if our what did I do? Let's reload it. Probably input the test case wrong. Oh, there's no apostrophe, no comma. It's fine. So we'll put this one here and put this one here, and then let's run the code. See what we get. So it's changed, right? The kite is still to kite. This kite, it both requires capitalized letter change. So we go to the first one. This go to the second. Here go to the first. Here go to the first. Nada, nada. Everything go to the first. Okay, so now we understand the rule. All right, okay, so we have the rule. Now we need to loop through everything in the query and go through the word list. And as I go through the word list, if I need to have any change, and we record that value, record that number, not number, record, because anytime, okay, so, all right, let's do it this way. So there's either match or non-match. If it's a non-match, we don't care. If it is a match, according to these two rules, right, as long as it's not a perfect match, then we're sure that the first encounter will be the one that you're going to take. Unless we hit an exact match. Okay? I think we have a general idea. Let's do this. Man, it took us a long time to parse the language, to understand the rule. Okay, let's take a look. Here Let's do the solution. All right. So what we're gonna do is we're gonna have a result, right? And then for query in queries, now we're gonna also do for word in the word list, right? Basically there are, so if, case insensitive, right? If Q is equal to, I shouldn't say that. Let's do this way, because the results will be the same length as query, right? The results will be the same length as query. So let's do this times len queries, and then we're going to put an I here, and then we do enumerate. So for each one, I say if Q is equal to query is equal to W, exact the same, then we always equals W, equals Q actually, and then we can break. We don't have to go anymore, right? Now else, we don't have to do else because it's already breaking. So now they're not the same. Elif Q dot lower equals W dot lower. All right, so this is this case, right? It will also be the first time that it's happened. We're gonna say this I will equal W. Let's all do W. Yeah, let's all do W, right? But we need to prevent this from checking again. So we also need to say first match. So we're gonna say first match equals false, right? So elif and not first match. We do this and then we set the flag to true. Now the next time I check, it will not change this unless we get this. Okay. Now else. Third one is I want to write a function. So else, it's basically something. Yeah. So it's actually if this equals this, or, right? It's going to be either it's equal or something we haven't written yet. I'm going to call it and not. Then we return rest. Okay. So we need to write a helper function. So we call it def check vowel error, right? Check vowel match. Let's do this. Check vowel match. So we have a word and a query, right? Both can be str, and then we're going to return a boolean value. And then here is going to be self dot, let's just say vowel match. Self dot vowel match. And then it's going to be word and Q, right? So, which means if it's capitalization match or vowel match, then, and also if it's the first match, we are going to record the value. But then in the future, actually, I'm going to put this one first so I can be slightly faster. So I'm going to say if not and, right? So if it's matched, then we don't have to do any of this. So this is what I'm going to do, vowel match. So the vowel match requires us to, basically, we have to do a counter. I'm thinking like we do a counter and we loop through everything in the counter and we order it. No, we're not order. Yeah, it's fine. We do a counter on a word and we do a counter on a query. and then we loop through everything in the word counter and try to see if we have the same count on the query. As we do it, if we hit a consonant, it has to be exactly the same. If we hit, oh wait, hold on, we already discussed this is not going to work because of keet, or like hair, here, right? So it has to be also position. So we have to do position-wise. So, okay, so the 2 has to be exactly the same length, and then we do position-wise. And the only thing that can mismatch is the vowels. Yes, I think that is the thing. So we say if len w is not equal to len q, or do we have a better way of doing it? No, I like to do it this way. So this one I'm going to return false, right? Then I'm going to zip for word letter and query letter in zip. In this case, I think it's be better we just specify this is query and this is a word, to make it more explicit. So we know what we're talking about. So we're going to zip word and query, right? And I want to say if this not equal to this, and this not in, let's do here vowels. Vowels going to be A, E, I, O, U, right? So we say if the 2 letters are not the same, and so they're not the same, and this word is not in vowels, or query not in vowels, right? If this happens, we're going to return false. Otherwise, which means if it's the same, then we're good. If it's not the same, and both are in vowels, so this not in vowels will be false. And then, hold on. So if they're not the same, and either one of them is not in vowels, then we're going to return false. Which means if both of them are in vowels, which will be, this will be false, this will be false, and this will not do. Okay, so I'm going to return true here and test it. So we only have one test case. Man, this test case is huge in terms of length. Have all this, and we have all the queries. I actually have someone I've written somewhere. I copied it earlier, but I'll just do it again. That's fine. So, I have 2 spaces. Then all these. Okay, and then the answer. The answer is this. Again, correct all the. Okay, I only have one test case. Yeah. So I'm gonna say that's gonna be a word list, queries, and this will be spell checker, word list and queries, and run it. Vowels is not defined because it's not vowels. It's going to be self.vowels. Okay, run again. We fail. Okay, answer and a result. Where do we fail? The kite, hair, empty. The answer is capitalized and I got lowercase. Alright. So the capitalization works, but the vowel match we got slightly different. Okay, vowel match, word and cue. And we're gonna get a word. What's our input? Our input is KETI and keto, right? So when we pass it in, oh, we have to lower them first. Yep, we have to lower them first. Otherwise, the upper and lower is not. Upper and lower is not working. Yeah, the upper and lower will show up as a mismatch. Yeah, there we go. Now we're passing. Okay, let's just do it. If we did not pass, then we're gonna think about other test cases. Judging. Oh, are you gonna time me out? Oh man, we're gonna get timeout or error. Yeah, we have a wrong answer. It's not gonna time out. Okay. Okay, we pass some and then we fail some. All right. Let's run a different test case. Just play around with this. So we have this. We're just gonna copy and paste, and then just change things around. Right? We change things around. I like what I did earlier with this. You know, we just throw in a few random stuff. For example, let's say just like what I did earlier. I like this one. So progressively, we are changing different KITE, right? So one capitalized letter, and then I also want to do like say 2 capitalized letters. Yeah, this is going to be a lot of combinations. So I'm just going to do a couple of these. ITE, right? And then KITE. Alright, so these are all the capitalized letter combinations. I'm going to take a look how this one looked like. Yeah, it's way too long. It can be a little bit shorter. Oh. Okay, and the answer is expected answer. I think this one's pass, right? Yeah, this one's pass. But we still want to keep a record of this. Yeah, we pass. Missing white space. Where? Oh, here. Okay. So now what we want to do is to change the letter. For example, we say A, E. I think I know. Hold on. Hold on. K, A, T, E. Yep. Yep. I think that is the case that we're arrowed on. No, we're not. Okay. How about KATE? How about this? We're also not arrow on this one. And what did we go wrong? These are all right. T. I don't know. O. Keto. Yeah, because they all need to swap. What if they both need to swap? And what if it's like this, right? Their only difference is this, and we both need to swap. Then, what if like this, and I put it here? So we both need to swap, and the T happens here. Shouldn't that be KITE? No, because the swapping is is higher in the order. What if I do this? Then there's no, yeah, so this one will have no capitalization change, and this one has capitalization change, and then both also have vowel change. What about this one? This one is still the first, because the vowel change. Huh. Then what was the error? What was the error? I don't know, man. It could be still the matching thing, right? Let's go again. Look at the matching. What does it say? Casing sensitive, right? And then I'd compare it word by word and say if they're different length, yes, different length definitely not going to work. If it's the same length, I pick them out, and then I say if the two do not match, and if either one of those is not a vowel, then it's going to be a mismatch. But if both are vowels, then we're good, right? Isn't that what it is? I cannot find a, What if I do, what if it's on this? Right? And then I do a change on, let's say, A. What's going to be? Yeah, it's still going to be the first one, because that's to consider the first. But if we do this, we know it's going to be the second one. What was the error? Yeah. Alright, let's change strategy. 4 has too many combinations. Let's just do 2. Right? So we do AB, AB, okay, and then we can have AB, 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 A and B, right? This is 4 combinations. Let's take a look how this one work. They all match. They all match. What about this? They all match. Capitalize them first. But still, they all match. Or, I'm doing a word by word difference. Man, it's hard to find the error, the bug. If I introduce 3, okay, ABC, ABC, and then I have more, right? So I can write it out. ABC, ABC, right? And then a BC, and a B, ABC. That's 1. What about if I have 2? So ABC, right? And then capitalize, capitalize, capitalize. So we do capitalize this, and then A, B, C, yeah. And then what else? A, B, C. Last one is A, B. That should be like 2 to the 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 2 to the third. Let's take a look. If we run this, there's no difference, man. Ain't no difference. Query word length is not larger than 7. It's very interesting. All right, I'm gonna check the error. Oh man, well, check the error. I need to know. I want to see what error do I have. Like, what in the hell did I miss? Okay. Let's just go to here. Check the wrong answer. How long is this? Oh dear God, that's long. So I don't even know where the error is. Can you see? Man, this is copy and paste here. I don't like this. This is a what did I get wrong? I don't see anything wrong. Oh wait, hold on. Okay. Oh, I have more. Wait, where am I? Jeez. Okay, so about here. It's about here. Okay. ZEO. Okay, so the thing we return. Did I miss something? We return W, right? Yeah, I said W. Did I not return W? Jesus. Oh my goodness. I don't even know which one is which. Hold on. I didn't even select everything. Okay. So that's this. Control F. My answer is ZUO, and the correct answer is ZEO. Do I have ZEO? Okay, ZEO is here. It's What about ZUO? ZUO is here. Huh? I answered ZUO. Hold on, let's go BHL. Okay, BHL is here. So input is ZEO. Right? BHL. Next one's not match. Next one is ZEO. And then I answer ZUO. ZEO. Okay, ZEO has a full match. Oh, I think I know. It's a full match with capitalized. I think I know. Okay, so basically, I think this is the problem. say like AB, AB, doesn't really matter actually. So one of them will be matching like this, right? So for this, no, actually no, it's gonna be matching but with this match and this one will be, let's say, EB, yes, this one, and we're gonna have EB at front. So this one at front, and then we match this. Oh, I think that is the error. What? Oh man, it's gonna be AB. I forgot to put this on. Yeah, I think that's the. Yep, here we go. That's the issue. So, okay, what this is saying is, capitalization takes precedence, right? This is what it's saying. Capitalization takes precedence. Okay, so capitalization takes precedence, which means if they match the capitalization later on, that means we need to have two flags. So this is going to be cap match and then vowel match, right? So we have V match. So this is called C match and V match, right? And then we say if this, there's no question. And now we say elif not C match, right? And this and the C match, then I equals W, and then C match equals true, right? And elif not V match and not V match and not C, because we know C match has precedence, right? So which means what we want is if we have C match, yeah, if not V match and not C match, and this, then we do this, and then we say V match equals true. Okay, so the logic is if hold on. So if not C match, so if we're taking in and see the capitalization is not matching, we haven't matched before, and then we match it, we set it, and the C match is true. So once we C match is true, the only thing we can change is if it's a full match. And if we go again here, we cannot do a vowel match. Okay, that's good. Now, if we have a vowel match, right? A vowel match, and we set a vowel match to true. So we will not do another vowel match, but we do allow for a C match. Okay, so with this in place, let's see if we make any difference. Oh, we can actually test it locally. Yeah, there we go. So what we're saying is, what the hell is this? Yeah, so this is the other test case, right? We have EB and AB. So basically that means the AB. It's gonna give us AB. Basically what we're saying is the capitalized matching is take precedence over the vowel matching. Judging. Oh my god, did we get it wrong again? Oh, this is going to be a bad one. We're gonna have to do this terrible Oh man. Oh, time limit. Now we have time limit. Okay, so this TLE, at least the solution is correct. Oh man, this one is harder than I expected, much harder. Okay, so a TLE because we're doing the same type of matching all the time, I think. Let's see. How many did we do? Yeah. Oh man, what did you close it? Ah, shoot. Go back to explore. So TLE, that means we cannot loop all the time, right? Well, we do find, I mean, there is a, let's think. I mean, what we can do, hold on, we cannot, I mean, we know there might be repeats, right? There might be repeats. So we have the query, and oh, a try? Is that what you're getting at? We need to build a try? We might need to build a try. Because if we don't build a try, we're gonna have, it's gonna be on squared. But if we build a try, that's gonna be on times 7, because each, yeah, if we build a try based on the word list, and then every word will be checked against the try, and the check against the try, the runtime is the length of the word, which is 7, which is 01, and we just need to go through this. That's okay. That's where the question is going about. I didn't realize it. We're looking for a try. Okay, that's fine. So to do a try, we have. I'm looking at this as an example. How are we going to do the try? So we have K, capitalized K, and capitalized K, and then we have a node as a root node, then capitalized K. We're going to lead to another node, and then it's I, and then capitalized T, and then finally E, right? Now the second one, how do we do this? It's a K, so it's not. Are we going to say it's not? It's going to be another path, but it's going to be lowercase, but the path will lead to the same node, all right? No, hold on. So we have K, and then now we have a lowercase k, and they shall belong together. All right, they shall belong together. Or not. We write the actual value at the end, KITE, and a K would just be a different route. So everybody would be a different route. So it's just a try. Oh, so it's just a try, right? So every word will be different. So we're gonna branch, like here we're gonna branch out, I, T, E, and at the last node we have the actual word. So this is gonna be basically 2 branches, and when we test it, so K, we're gonna match to the one that fit us, okay? And then we're gonna go I, T, E, and then we match, we go to the end, and then we find the value, and then return this value. For query on this, we match the first one, so we already go to that branch, and then we keep matching, and then at this next one we have the not lowercase t, but we have uppercase t. We keep matching. It's good. Okay, this one is good. And if we hit like this, KETI, right? So K, we're already going here. Ha! We're going here. But KETI, we're gonna matching on this one. Oh man. If we switch based on capitalized letters, it is not going to work. Right? So we cannot switch. And we go, then we go in two branches. Is it? It has to be a try, right? It has to be a try. And the question is, if it's a try, how do we decide which branch to go to? Right? We already have the problem. We have this KETI, right? It's gonna be go for this one because that's the first one we have a vowel mismatch. But how do we know that we need to go to this one instead of this one? Right? We have the lowercase k. It could go this one, it could go this one. And if we keep branching, so you're saying that we just need to keep branching? I mean, it's only 7 depths, right? Even if we branch, so like lowercase k, we know we cannot decide. So we branch. One go here, one go here. And next, I, no branching, keep going. And then I'm thinking about like KIT, like really matching. And then T, this is this. And then at the end. So if we branch, right? If we branch, when we get to the end, we take the branch that has the perfect match. If we do not have perfect match, we're going to take the one that we encounter first. But how about this test case? All right, how about this test case? We have E and B, and we also have A and B. So one's EB, one's AB. The word coming in is A and a capitalized B. So immediately I'm going to the A branch. But no, I actually can also go to the E branch. Because if it's E and a capitalized B, which one is it going to be? That's an interesting question. That is a very interesting question. So what if I have EB, AB, no, not EB, E and capitalized B. And then the other one I have AB. What is this one going to return? This one still return AB. So if I have a single capitalized mismatch or a single vowel mismatch, I always go for a single capitalized mismatch. But if this one is not B, if this one is a different value, then how about we not do B? Let's do I, right? And this one is a lowercase I. If I have an uppercase I, what is this one going to do? This one is still return AI, which means I go to this branch. And what if I do? I'm trying to think like how can the try be applied, right? I have A. I need to try both branches, and I did. And then next one is I, and this one is a full match, and this one is a full match, and this one is a capitalized match. But this one, the first one is a vowel match. So we're gonna rank them out. So rank them out will be a vowel match and a full match. This one will be a full match and a capitalized match. Let's read again. Match the word up to capitalization should return the first such match. Match up to capitalization. So this is a match up to capitalization. So we need to also keep a track when we match. We keep a track on how they match. And then we can compare how they match and take the one. I mean, we'll have like full match, right? Full match. It will be like, let's say, an empty, right? And then we'll have one that has some V, some C, some C, some V, right? And then we're gonna read them, and then we're gonna return the one that has, like, if it's a full match, we'll return that one, no question about it. If it's not a full match, we're gonna return the one that with a V, with a C. If we have two, and then there might be more, right? It'd be more. Hold on, I'll be back. All right, I'm back. I was thinking about the order of the matching. I think I have a new idea. So based on what we have, I mean, we know this one is correct, right? So what this says is, if there is a capitalized matching, which means there's no vowel match, just capitalized letters. If that happens, that takes precedence. And if we have a vowel match and a capitalized match, we always go with a pure capitalized match. And among the vowel matches, if we have, I think it doesn't really matter. If we have a vowel match and within the vowel match we have capitalized match, that does not matter. It's basically whichever we encounter first. So here is the hierarchy. Full match, always high, and then capitalized match, and then vowel match. Right? So that is the hierarchy, which means we can establish the order on the try. So it's still going to be a try, and we have to branch, right? If there are capitalized letters, two options, we have to branch. If there are vowels, like vowels of five vowels, we have to branch. Right? There's no way around it. We have to branch, and how is this gonna? Are you saying that even if we branch, I mean, look at this. We have 7 letters, right? We have 7 of them. Man, so for every one, at most we can branch 5 times. So it's 5 times. First level we can branch 5 times, at most, and then yeah, it can branch 5 times. And the second level, each one is also going to have like five times branch. No. It's not going to be 5 times. But depending on how the words are written, right? So it's longest is 7. So if I say like A-I-O-U, and then we do another one, and do another one. Man. No, it shouldn't be, because one of them will match. No, even if I match, I still need to keep going. If I match, can I just stop? If I match, but you still have to stay on the other lane, because it could be the following one does not match, right? If the following one does not, that's an interesting one. Let's see how this one goes. This one goes here because this one needs to do a vowel match, and this one also does vowel match, and then there's only a vowel match, so this one goes first. Otherwise, this one is just a capitalized match, so we go here. Okay. So in this case, I have to branch out, even though I know a match, but I need to branch out. And then for the second one, it's just a single. But if I have I'm just thinking about the complexity. Right. And then if I have another one, I just change the order. Right? Then we'll branch out, and then we have to branch every single time. Right? So this one will branch twice, and then here. Oh, hold on. Depends on. I don't think we need to branch all the time, because if initially, it depends on initially. Say initially we have 5, right, at most. What? It's actually no, it's 10, because each one can also have its capitalized version. So we have 10 at most, and then within 10, there's our first branch out 10, and the second level, it could be 10. It's the same thing, right? We just Yeah, it could be the same thing. The third level, it can be, so it's be like 10 times 10 times 10 times 10, like 10 to the 7th in order to go through all of them. Let's try it. Let's try it. Maybe it won't be that cruel, but we have to try it. This one TLE, yeah, this one's definitely not going to use. It's not useful. We cannot use it. I feel like we're getting a little bit stuck here. I think this is not that hard, but we kind of got stuck here. So if we build a try, we have to build it first, right? So we're gonna say a try node, right? A try node and be, if I remember correctly, from collections import default dict. So I think a try node is a default dict. Right, a default dict, and then a lambda try node, right? I think this is this how you define try? So each one is going to be itself. Not sure. Honestly, not sure. Let's give it a shot. This is what I saw in the past. Collections import default dict. All right, so we're gonna say a equals default dict lambda a. Okay, so a. What if I say a AA? I don't know what it says. AA. What is this? It's a default dict. I think this is right. AA. I can keep going. Yeah, A, and then it has a B. Yeah, I think this is a definition. I don't know. I don't know. So do I have to? Is this a lambda? Gonna be a default dict try node. Yeah, I think this is the case. So try node itself is just a function. So if we call a equals try node, and then we can say a. We can keep going. Yep, I think that's the definition. It's a lambda function, the default dict itself. So what we're doing is gonna say for word in word list, right? And it'll be for w in word, and we say we have a root equals try node. What we do? So we're gonna say root root w equals a. How do we do try? For w in word, say while root w, right? While root w while true, next node equals, man, okay, so for each word, we're going to have a node equals root, right? Node equals root. And then for word, for W in word, node equals node W, right? Node equals node W. So which means if the W exists, we're going to take out its next node. If it does not exist, it's going to get a node as well because it's default dict. If it does not exist, it will just return to you an empty thing. And then we just keep going. So that is a okay. All right, let me see how this one looks like. So at the end, I think we want just to print root, see how it looks like. So we're going to say this is 2, solution 2. And then, okay, so we have E, B, and A, B, and N. Okay, that's good. But at the end, I want to have another one. So once everything is done, we're going to say node index. Right, we're going to do index. So we don't have to save, we're going to save the word itself. Word equals word, right? So which means we have this, and at the end we have the word itself, okay? So that is the try. So we built the try. Actually, I want to put this one outside so it doesn't pollute. So we need to do self dot, right? So we build the try, and then what we're going to do is for query inquiries, right? Now we're just going to match around the try, which is actually going to be a recursion. So I'm going to say it's actually DFS, and we have the try, we have the root, and what do we need? So we need current letter, which is the word, the query, in the query, right? We need the index, which is pointing to which word we're looking at. And let's do this first. So, and a node, and the current node. So we're gonna look into the current. Oh, we need a. We can't just pass in the current word, current letter. So current letter, and we're passing the node. And so we're gonna look for this letter. If the letter is a vowel, then we need to go to. So we also need vowels. Right, vowels. Actually, we can put the vowels instead of this. We're going to put into a list. It'll be easier to handle. Right. So we're going to say easy case is if the letter is not in vowels, right? So if letter not in vowels, which means it's a consonant, and right, and letter lower not in node, and letter upper not in node. So that means um, hold on. No, I think index will be easier to handle. So we're gonna have query, we're gonna have index, right? And then the first one is if index is larger than the length, right? Then we know we reach the end. I'm gonna return basically two things. Hmm. Can we do like a check at each step? Like at each step, we can check if it's we have to check at the end when we match everything, because it's not a sequential check. All right, it's like an overall check. All right, so every time if we match, so okay, so what we do is at the end when we go to the last node, right? We go to the last node and we end up with the value. But when we end up with a value, that doesn't mean anything. Like literally, it does not mean anything if we end up with a value. Because we end up with a value, we just return the value. Now we're returning the value. Yeah, we're returning the value. Okay. So we can decide when we return the value, which value to take based on the current status. Okay. So we're going to say the match status, right? So we say if index is equal to len query, which means we go to the end and just return node. And return what? Because we can, it's possible to match something, which means at each one of them, node get its this one and node word default dict. So node word is empty. Okay, let's also take a look if this is what we want. No, we don't want. So we're gonna return node dot get word. If it's not, we're gonna return this. Yes, so that's when we end, right? And during the matching phase, when I say letter is query index, right? So we have the letter, and we are going to say that if the letter is not in vowels, and we say the letter lower is not in node, and the letter upper is also not in node, which means the letter is not a vowel, it's a consonant, and it does not exist in the current node. So this immediately going to return empty string, right? So the next one will be the node is a vowel, right? If it's a node, okay, the node also, hold on. Oh man. Match status. Okay, so the letter is not a vowel, but one of them. Okay, hold on. Uppercase, lowercase go first, right? So if letter in node, right? If letter is in node, then we do DFS query index plus 1 node letter and match status. We don't change the match status. I don't even know what match status is right now. I think it's most likely it's going to be a set, right? So when we say res1, it's going to be this. Else, so the letter is not in node, so it does not exist. So else letter dot lower node, then we have result 2, which is letter dot lower, and the match status has to be then we say match status dot add capitalized, and then we pass it down, and then elif letter dot upper node. And we do this again. We also have to, if the letters lower is in, no. It's going to be like this, right? Because we want to visit all of them. If it's in it, we do it. If it's lower is in it, we do this, and man. It depends. If it's already in there, then we don't do it, right? So okay. Append. Then we're gonna say match status.pop. Then it's the same thing. If it is in it, if it's lower in it, and this is going to be upper, right? This can be upper in it. Now we're looking at is, so this is going to be result 3, right? So we have no result. It could be it's not in there. So man, this is driving me crazy. We have all these solutions and we don't know which one to take because it's actually based on which one comes in first. Which one comes in first? Oh Lord. I feel like I'm falling through this. How is this so hard? It's impossible. It's an easy question. Is it possible I'm caching this? We do a try, right? But you also need to record not only the. I don't think it's actually recording the word. It's actually recording the index, because I think index is more important, so you know which one to take first. So I enumerate this, and then we're gonna do index. It's gonna be I. right? So we have index. So when we return, we're going to get index. And then index can come out, and say -1 if we don't have any, right, when we return the index. So what we're looking at is the current letter, right, and we have a node. And we have many options for this one to go. So when you say if, so I'm going to say match indices, right? So every time I can just append the match indices. So if letters in it, and then we do this. Now if letter not in it, but its lower is in it, then we do this, so we know we did a change. And then we can take a look, and if the letter, hold on. The decision shall only be made at the end. Now the decision shall be made. So when we reach the end, we know how much we did, right? We can apply this. We can apply this, like this check. We can apply this check at the end to know how we get here. So that means we don't have to use the match status. No, we don't have to use match status. So basically what we're saying is at the end, right? At the end, if we are, it doesn't match a full word, then we can return. So here, when you say if index is not in, if index is not in node, then we return empty directly. Empty and empty and empty. Else index in. Now I'm gonna say if query is equal to number, word list index, not index, word node index, right? If these are the same, then we're gonna return, then we're gonna say the match status is equal to full match. Yeah, if it's this will be full match. And we also say if query elif query lower equals this lower, right? Equals this lower. Then we say the match status is a capitalized match, and else we know match status must be a vowel match. Now in a return, what we're going to return is we're going to return what are we going to return? Because they represent different. No. It's the same word. So we're going to return this. This is the actual word. So we're going to return the word and the match status. Right? We're going to return the two things. Return word and a match status. So that's in the end. Otherwise, all we're going to do is what we're going to do is do DFS on, so we we identify the match status at the end. So every word matched at the end, we know what type of matching it is. Now we need to bubble up. We don't need to bubble up. Why do we need to bubble up? We don't need to. We don't need to. No, we don't need to bubble up. All we need to do is just branch, 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 and then reach the end, right? It reached the end. It reached the end, and then we push this into some central storage, right? So we have central storage. We're going to have, like, say, these three cases, and then we just push the data in, and when the push in is going to be index. Yes, it's going to be index. So this is to create a try, and then we're going to say the data is going to be F full match, right? Full match, C match, and V match, right? In 3 situations. So if index is in node, right? I'm going to say this. If query equals this, then I'm going to say data f dot append node index, right? Else if this, and then we're going to also say data c, and then this is going to be data f data v, right? And then that's it. Else, which means if it's, and then we don't do anything. Right. So else is when it's not, then we're going to decide which one we're gonna go. So we're gonna first get the letter. The current letter is this, right? Now we say if letter is in self.vowels, if letter is in self.vowels, then for vowel in self.vowels, for self, for vowel, for v in self.vowels, if v in node, we're going to do DFS query index +1 node v. We actually make it simpler. We're going to say, but it's not going to be node is going to be a dictionary if dictionary is going to be empty, right? Dictionary could be empty because we're going to, no, I don't want to change. Let's just do this, right? Node is just going to be a dictionary, and then we're going to have and we can check here. If v is in node, then we go to the next node. This is for if L is in vowels. Else means letter is not in vowels, right? Not in vowels. Then we're going to say for letter dot lower. Then we're going to say if letter dot lower in node, then we go this, right? It will be letter dot lower, and if it's if letter dot upper is in it, then we're gonna go upper, and we don't need any of this. Right, that's the DFS. It looks just way too complicated to me. So yeah, so what we're saying is if index is equal, right, and then we can determine what type of match it is. And if it's not equal, that means we need to check where do we go. Let's say if it's a vowels, because we can change, we're going to go to all possible vowels if it exists. Yeah, we can write it this way, like for v in self.vowels. Yeah, it's fine. And then we say if it's a consonant, it can only be a lower or upper or lower. So we do both, right? If it exists. And then at the end, what we're going to do is for each query, right? So result is going to be this, and then say for query. Actually, I have that. So for query, inside queries, oh man, the data has to be here, right? Because each query has a new data. So we have a data here, and then we do, let's also pass data here as well, node and data. What we do is we do DFS query, and then we start from index 0, and the node is going to be root, start from root, and I'm passing the data. And after we've done this, we're going to say if data f, we're going to say res.append full match, so we just put query, and else, right, elif data c, right, because c match is higher, so out of data c, we're gonna say res.append earlier match. So it's gonna be data c min data c is going to be the index, and then we say word list min data c, and else, which means it's gonna be a vowel match. Then we take this, and then at the end we return this. Oh, I'm not sure. This is very convoluted. Okay, I have some issues here. Issues here. Oh, I have more. Hey, Dios míos. What is this? Take 0, but 1 was given. Where? Undefined name try node. Okay, which means I cannot do it here, I guess. Okay, so we do try node here. Try node here. And also do vowels here then. It's fine. It's not taking any more time. Okay. Vowels is assigned but never used, because I have a self.vowels, which we should not use. DFS is missing one required data. Okay, so we need to put data at the end. Data at the end, because if data is changing, if data is changing, I think it's actually fine. I don't think we need this data though. Yeah, I think we don't need this data, because data is global. Okay, is not defined. Word list, a word list, lowercase. So word list will be lowercase. Okay, we did go through, but we have an error. Answer is AB, but we get EB. Why is that? To know why, I think we only need to look at we're not just print data. Take a look. What did it look like? Data has V change for 1. How is this V change? This is not V change. This one should only be C change. Okay, we have some trouble here. I said, oh, the lower. Oh my god. Okay, this one pass. How about all these? Main argument is an empty sequence. Okay, so elif if data f, elif data c. I already do data c. How is this main argument elif data v? I have to do this as well. Okay, so basically I do this. Oh, then else, like none of these, right? None of these, then rest dot append. I forgot about the empty case. Then we pass. Oh man, I'm not sure. I'm not sure at all. This is. If it time out again, I think I'm gonna give up on this one. It's already been too long. Let's try. See if it times out. Pending, judging. Oh, we got a wrong answer. Expected. How is wrong? Oh my god. We haven't even fixed all the test cases yet, let alone to deal with time stuff. Yeah, I'm just at this point. All I want to do is pass. That's all I want to do. So I'm going to use any way possible trying to pass. Okay. Why? We have only one tree, right? And then what do we have on the data? Data is empty for all of them. Did we reach the end? Did we reach the end? I think we did, right? I think we did here. We didn't reach the end. How come we did not reach the end? The letter is this. The letter is in vowels. It's not in vowels, so upper in lower. No, we should go to lower, and then O is in vowels. So we loop through all the vowels, and then if one of them in node. Oh shoot! My God, I know. It has to be. Oh man. If V dot upper in vowel in node, so we go upper, and we also need to do lower. Man, if this one pass, how is this? How is it possible that this one is faster than the other one? So yeah, that's true. We have to do like this, and yeah, it's fine. All right, try it again. Pending, judging, wrong answer. Ugh. You. Oh man. Ugh, unbelievable. This has to be. Did I even check? Oh, I do the lower and lower. But here I cannot do lower and lower because I need it to be exactly the same. So I mean, I can turn this into a set. That's actually fine. And then I'm going to just do A, E. Actually, no. So L, E in vowels. Okay, actually it's going to be, I think this is better. This is cleaner. E, I, O, U, right? And then in here, A, E, I, O, U, I just say vowels. For vowels, I don't have to do the upper and lower thing. If anything there, and then I denote V, because I include the both upper and lower case. Okay, try it again. Pending, judging. Oh shoot, it's the wrong answer again. Oh man. Terrible. Esto es terrible. Okay, let's see how many test cases we go through. Oh, wait, almost. It's almost done. So we just need to find where do we have the miss. Did we see it? Okay. So at the beginning. I think I see the light at the end of the tunnel. Okay. Should be IIY, but I got it AAY. Oh man. This is a struggle. This is a struggle. How am I even be able to tell where IIY is? Don't be discouraged. Let's do this. Let's do this. I think all we need to do is to first find UCK. Okay, so what we're looking for is UAY, right? We're looking for UAY, and IIY is here. Oh man, this is not helping at all. IIY is here. How about AAY? I don't know. Is AAY? Oh, AAY is higher than IIY, right? Yeah, AAY is higher. But I already said, so this is a vowel change, right? This is a vowel change. I already said that I'm going to look for the minimum, which is the smallest. Right? I already said I'm going to look for the smallest, which is the early occurrence. Oh. Oh, here. Got it. We have to do okay. If hold on. Equals min I node.get index. Math, and we have to import math. I know it's all imported already, so we're gonna do math.in. Yeah, because it's the same thing repeating, and I always get the latest one. So if this, then we shall be correct. I mean, oh man, go through all this. I'm not gonna go through all this. I'm just gonna submit it. Come on. Come on. Yes! Oh man. This is struggling to the maximum. Finally passed it. Oh my god. Oh Lord. Very, very convoluted. And then, you know what's going to happen when I look at the actual solution? Somebody in the writing like 2 lines. Man, this is a struggle. I think this is one of my most struggle in so far. Unbelievable. Unbelievable. Alright, so yeah, that's the issue. We have to always record the first occurrence. Which I can actually do it, I think I can do a better way. Instead of calling min, I can just call it if. I can just say like if index not in node, then we do node index equals I, right? Yeah, that I think that will actually be a better solution. Well, we're gonna take a look at the details, and we're gonna change this, and then we don't need math, right? I hope this one is actually going to be, yeah, pending, judging, yeah, they accept as well. So, all right, take a look. Oh, terrible, terrible. There are better solutions. All right. This is a very, very convoluted method. It uses a try to pre-process the word list, and for each query, we go through the try to see if anything matches. The rule to go through the try is that if the query's letter is a vowel, we DFS into any possible vowels, any vowels available. When any vowels available, both upper and lowercase. I mean, no, because you don't know at that point. Unless we put that at every single time. I don't know, man. If we have an index, I'm thinking if it's possible to reduce the. No, it's not. We have to go through every single one of them. So both upper and lowercase. If the letter is a consonant, we go through its upper and lowercase. If they lowercase, should they exist in the try. At the end, if we have reached the end of a try branch, we determine whether the match is a full match, a capitalization match, or a vowel match. The full match has higher priority to cap match, which has higher priority to then vowel match. Okay, so it's actually then. Runtime is 7n. Actually, no. I don't even know what the runtime is. It depends on how many dissection. Well, I mean the runtime. The runtime depends on how many branches we visit during the traversal of the try. The worst case is that the try consists of only vowels of both upper and lower letters. Then we are looking at 10 branches per level, which can result in astronomical runtime. But the average case should be on, because we expect each try level will only branch will not branch too much. Will not branch out too much. The runtime we got is 308 milliseconds, and we get a terrible 16% ranking. Alright, at this point, my brain cells are all dead. Like, literally all dead. Oh my god. Alright, let's take a look at hash map. What? That's it, hash map. What the hell? Total content. Huh? Hash map. When a query is at match, up to capitalization, when a query is match up to vowel errors. Hash table to query the answer. In the first case, we hold a set of words to efficiently test whether our query is. The second case converts the word from its lowercase version to its original word. The third case, we hold a hash table that converts a word from its lowercase with vowels masked out. And then reading the problem carefully. Isn't that this one? But how did you not time out? Oh, words cap. Word low. So each one of them is, what's it set default? Okay, vowels, I think it's just removing the vowels, right? Oh yeah. We replace the vowels with this. So for each query, if it's imperfect, we do this. If it's the lower in words, if in words cap, and then that's a dictionary. That's a dictionary. Ah. Okay, I see. Poor description. Oh, okay. But people have the same problem as I do. case where there is a no, this is no, that's not true. All strings are English letters. Sub, yeah, this is actually, wait, when you do sub, is sub all of them? Wait, do we sub all of them or sub only one of them? I just do read a few times in the past. A equals AE, okay. Say read sub, pattern will be AEIOU, A, and then we sub, sub with, and then I'm gonna pass in A. Sub AEIOU. It doesn't work. It does not work. I did exact the thing here. It shall work, right? Huh? Oh. Oh yeah, of course it does not work. It has to be it has to be this. There we go. And the reply. Should be this. Oh, I have the same problem. It doesn't matter. Should be with this, 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 this. All right. 2 hash map, 3 dictionaries. Aye. Now I see. Now I see how this one goes. Now I see. Oh yeah, this one's even better. Choose one of them. Right? You can do this as well. Choose one of them. Just do this. Yeah, choose one of them. Man. I'm not feeling well. I am not feeling well. This is terrible. This is terrible. Oh, we saw this one already. Well, I mean, it is terrible because we spent 2 hours on this, more than 2 hours on this. We have a TLE solution first, and we tried our best. We actually did write a solution that passed, and I'm proud of this, even though it's not the official solution. But we did write one that passed, and it took a lot of efforts to pass. I don't even think anybody used a try. We can actually post this because nobody is using try. It's just, oh, we have try here. Yeah. Ew, oh, yeah. Oh, ah, damn. Oh, this is long. This is long. Very, very long. Well, seeing this, it gives me confidence that our try solution may be not that bad. Can I search to see anybody using try? So try and BFS. Yeah, they all did this before. 2 tries. Anyway, all right, let's implement the correct solution and call it a day. Okay, so the correct solution will be 2 hash maps, 3 hash maps. So it's going to be full match. So I say full match, right? And then I'm going to say cap match, full match, and vowel match. Let's just say F match, C match. No, C match and V match. So all three is going to be this. And then for word in word list, right? For word in word list, F match dot. This is just going to be a F match is just going to be a set. Right, it's going to be a set. We're going to do a C match, and so C match word dot lower. We also have a. Don't we also have a? We don't. We actually don't. We should record the first thing, right? We record the first. So we just say equals word, and I say if word dot lower not in C match, then we do this, and then we say, all right, we say lower word equals word dot lower, and then I want to do it once, so lower word, right? And then we're gonna say swapped word equals I'm gonna call it red, and I don't need math. And then we say equals red dot sub r can be AEIOU. We sub it with star, and we're gonna do word, and we say if swapped word not in V match, we say V match swapped word equals word, right? So this is the prepare, and then rest equals this, say for query in queries, if query in full match rest dot append query, elif query dot lower in C match. I say lower query equals query lower, then swapped query equals this thing query. So it's going to be a lower query, then let's start append and say C match lower query, elif swapped query in C match, no V match, let's start append V match swapped query, else there's a none match rest dot append empty string, and return rest. Okay, let's run it. We have error. Where? Kite. Answer is kite, and kite should be result is lowercase. Oh, why? Well, we also have this one's error. Yellow. we should have this. C match is the lowercase. This match shall just be. Oh, I see. I see. It should be lower query. Let's do a lower query, and then this is the same thing. It's gonna be not instead of word, it's gonna be lower word. There we go. Now we pass. All right, put it here. Oh man, look at this. Jesus, it's probably one of my worst performance. Run it. Pass. Yeah, that's the regular solution. All right, I admit that I didn't think of this solution at all. This is the official solution using two hash maps and a set. It is a better solution, both in runtime and in logic. Both in runtime and logic. And then we run at O. I mean, it's O. I don't even want to say O what. It's just we run at 188 milliseconds. Give us 49% ranking. All right. Using hash map is, yeah, all words, all matching via changing capitalization. This is all matching via swapping vowels. Must use lower. I use lower to avoid. No, it's fine. I just must use lowercase word to avoid further comparison in letter case, in capitalization. Okay. All right, that's it. That's it for today. Man, we did bad one. Very, very bad. But doesn't matter. Tomorrow we're gonna bounce back. All right, that's it. Adios.